All right. So 10.1 and 10.2 have to do with what's called a chi-square distribution. So when you look at your table of values packets, you're looking today at the one that says table 6. It's a chi-square distribution. So we're going to be using that in a little bit. Let me have that out. Okay. All right. So back in chapter, I think it was chapter 4, we talked about binomial experiments, and those are going to pop up on your exam again. Those were where there's two potential outcomes for an experiment, and then we showed that that makes a normal curve, and we could use, our z-values and things like that to go along with it. A multinomial experiment is still a probability experiment, but now it's going to have more than two possible outcomes. So we're going to have categories of answers that you can have instead. Categories for this lesson are going to be labeled with the variable k. So instead of having sets of points, n, like we saw in chapter 9, we're going to have categories, and we're going to use a k to represent that. Okay, so only if you have more than two categories do you have to worry about any of this stuff. If there's only two categories, we would do the binomial experiments from back in chapter 4. Okay, so a chi-square goodness of fit test, a lot of times it'll just be called the goodness of fit test, tells whether a frequency distribution from a probability experiment fits an expected distribution. And that expected distribution could be lots of different things. It could be normally distributed, like a bell curve. It could be, you're going to see the word uniformly distributed, which means it almost looks like a rectangle. It could be skewed left, skewed right, or just certain percentages in different categories. Okay, so we want to know if it fits that expected distribution. It's also going to tell us if it is that sample a good representation of the population that we're analyzing. When we do chi-square distributions, we're going to have observed frequencies and expected frequencies. Observed frequencies is what is actually observed in the sample data. So that is from the experiment or from the probabilities that are run. Expected frequency is calculated from what is expected to happen. And that's what we're going to be analyzing. We expect it to be a bell distribution, or we expect it to be uniformly distributed, or we expect it to have these certain percentages. To calculate an expected distribution, we're going to use this mini little formula here. E sub I is the expected frequency. N is the number of trials, and so that's like our sample size that we're used to using. And then P is the assumed probability, what we assume it will be for the population. So we just multiply the number of trials, or our sample size n, times the expected probability for that category, and we get the expected frequency. Okay. So that's the first thing we're going to look at today, is just making sure we can get an expected frequency, because then we need that for our chi-square distribution. Okay, so in this problem, it says a tax preparation company randomly selects 300 adults and asks them how they prepare their taxes. The results are shown at the right. Find the observed frequency and the expected frequency using the distribution here and here for each tax preparation method. Okay, so on the top right, you have survey results. If you have survey results, you have observed frequencies. Okay, so those in this problem are given to you. In this survey, it was observed that 63 people used an accountant and 40 did it by hand, and so on and so forth. Then down here is what they're comparing that to. This is what they expected people to answer. Before the survey, they expected that 24% would use an accountant and 20% would do it by hand, and so on and so forth. So if we want the expected frequency, we used F for frequency back in the day, so I'll just abbreviate that. All we have to do is take our expected probabilities, and we've got all those percentages already, and multiply them by our n. Okay, so for the first category, it'd be 0.24 times n is 300, and that would be the expected frequency. So if 24 people, where's on the calculator, if 24% of the 300 people said they used an accountant, we would expect that 0.24 times 300, 72 people would have answered that they use the accountant, okay? And then you just continue it from there. So I would do 0.2 times 300 gives me 60. 0.35 times 300, 105. 0.06 times 300, 18, and 0.15 times 300 gives me 45. At the very end of your expected frequencies, they should always sum up to your n, your sample size. So in this problem, it all sums up to 300. So that's a quick way to check that your expected frequencies are correct. Okay, so observed is what actually happened in the survey. Expected is what we expect to happen before the survey starts. When we get to the chi-square distribution, the goodness of fit test, we're going to see, does our survey match what we expected to happen? That's the goal of all this. Okay. Questions here? No. Okay. You guys try this one on the next page. It says the pie chart shows the distribution of healthcare visits to doctor's office, emergency departments, and home visits in a recent year. A researcher randomly selects 500 people and asks how many visits they make to the doctor in a year, 1 to 3, 4 to 9, 10, or more, or none. What is the expected frequency for each response? So I'll give you a minute. Okay. 76.5, 252, 114, and 57.5. And we don't need to worry about rounding these. It's just an expectation for now. We're not worried about, exactly 77 people or 76 people or something for that non-category. We just use this when we're contrasting that with what is observed in the actual survey later. Okay. Any questions on those? Just multiplying the percentage by our n, 500, getting the expected frequency. Okay. All right, so on to a chi-square goodness of fit hypothesis test. So first we have to know how we're going to write the null and the alternative hypothesis. Generally, when you do these, the null hypothesis will state that the frequency distribution fits the expected distribution. So it might say the frequency distribution is uniform, if that's what they wanted to say, or the frequency distribution is 25% in the first category and 75% in the second category, or the frequency distribution is normally distributed, okay, whatever they want us to test for. And the alternative hypothesis states that the frequency distribution is not matching the expected distribution. Okay, so for example, there's an it's written up here for the tax preparation problem we did a couple slides ago. The null hypothesis is that the expected distribution matches or what we expected to happen. The 24% for the accountant, the 20% by hand, the 35%, 6%, 15%. The alternative hypothesis is that it differs. It's not what is the expected distribution. Okay, so very plain and simple. Again, the claim is going to be the null with all of these when we do them. Okay, well, I shouldn't say all. In most cases, the claim will be the null. We're claiming that it fits a certain distribution. Okay, all right. Steps that we use are given here. The chi-square distribution shape looks like this. There's a picture of it on the very first page. It is always going to be a right tail test because of the distribution of this variable. Okay, so we don't have to worry about left tail, right tail, or two tail when we do these. We also don't have to worry about those two categories we talked about a lot with. There's at least a sample size of 30 or normally distributed. Instead, the thing that we check, and it's kind of within the work that we do it, is that each expected frequency is at least greater than or equal to 5. As long as all of your e's that we just practiced calculating are greater than or equal to 5, you can do this test. So we're going to write the null and the alternative. Alpha is going to be given to us. We're going to use degrees of freedom to find a critical value. Degrees of freedom are k, the number of categories, minus 1. Okay, so the only time we use that n minus 2 for degrees of freedom is when we have two different variables that we're comparing, our x's and y's that we use for the regression stuff. Rejection region is going to be in the right tail based on the critical value we find on our chart. Then we calculate our own chi-squared statistic. So that looks like kind of a cursive X. It's called a chi. And O, remember, is the observed frequency of each category, and E is the expected frequency. So we're going to do this little calculation. We're going to use a table of values to help us. We're going to find O and E. Then we're going to do O minus E and square it. So it's the difference in the two squared divided by E. And then we're going to add that category up. That sum will give us our chi-squared statistic that we're going to compare to our rejection region. Just like usual, if it's in the rejection region, we're going to reject. If it's not in the rejection region, we don't reject the claim, whatever it is. Okay? Ready to practice one? All right. So we're going to do this one. It says a researcher claims the number of differently colored M&Ms in a bag of dark chocolate M&Ms is uniformly distributed. Okay, which means there's the same of each color. To test this claim, you randomly select a bag that contains 500 dark chocolate M&Ms. The results are shown in the table below. Alpha equals 0.1. Test the researcher's claim. Okay, so we have each of our colors. That will give us our K. Our K is how many categories are. How many categories are there? 6. Okay. Then we have a frequency. You need to know if it's an observed frequency or an expected frequency. This is what was in the bag, so it is an observed frequency. Okay. We also need an expected frequency. Okay, now what is expected here? It's expected that there are the same amount of each color of M&Ms. So if we have 500 M&Ms, and the expectation is that there's the same number of each of them, how could I figure out E here? Right, so I already know the total. It's 500 divided by 6. And you're going to get the same E for every category if it's uniformly distributed. So it's 83.33. I give it a couple decimal places. So if there were the exact same number of each color in the bag, there would be approximately 83.33 of each M&M. Okay. All right, so that's our O and our E in those categories. Then you need the following. You need O minus E squared over E. And that column, we're going to sum up, and that gives us our chi-squared value that we're going to compare to the rejection region. We'll get to that in a little bit. Okay. By the way, all of those E values were greater than or equal to 5. So we're good to go as far as this testing goes. Everything in that category was bigger than 5. All right, so now we need our calculator. Make sure I do this right, guys, so we don't have an issue like this. Double check me. All right, so for the brown category, I'm going to do 80 minus 83.33. That gives me my O minus E. And then I'm going to square it. And then I'm going to divide by E, 83.33. And I'm going to give it 3 decimal places, 0.133 you get for that first one. Okay, and you're just going to do the same thing for each category. Take the O, 95, bless you, minus 83.33. Square it, and then divide by 83.33. I get 1.634. 88 minus 83.33. Square it, divided by 83.33. 0.262. 83 minus 83.33 squared divided by, that's a little one, 0.001. 76. Square it, divide, 0.645. and then 78. 0.341. Okay, and then we add them all up. Make sure I did that right. Nope, I didn't. There we go. 3.016. Okay. All right. Null and alternative hypothesis. What's the null hypothesis? What is the expected distribution? The M&M colors are what kind of distribution were we expecting? Uniform. Uniformly distributed. And that was the claim. Okay. The alternative is the colors are not uniformly distributed. Okay. All right. We had K. We can get degrees of freedom, which is K minus 1, which here is 5. All right. Find our critical value of chi-squared on your table now. Okay. Our alpha, our level of significance given to us was a 0.10. So in your table, you're looking at 0.10, and you're going down to 5 degrees of freedom. And you should see a chi-squared statistic of 9.236 from your chart. Okay. All right. So make a little sketch. It's going to look like a right skewed curve. And 9.236 is going to be the beginnings of our rejection region. Always a right tail test. Is 3.016 the statistic we found in the rejection region? It is not. So do we reject or not reject? Okay, so we do not reject, and then we summarize. So is there, and it's the null, we're rejecting or not rejecting, is there or is there not enough evidence? There is not enough evidence to reject or support. Reject the claim that the M&M colors are uniformly distributed. Questions on a chi-squared goodness of fit test, hypothesis test? Okay, we just have one more problem and I'll get you guys started on it, and then that will be it for today, I believe. Okay. All good here? Okay. So last problem is yours to try. And like I said, I'll get you started on it. It says a sociologist claims that the age distribution for residents of a city is different from the distribution of 10 years ago. This time, the claim is that it is different. So the claim is going to be your alternative hypothesis here from an expected distribution of 10 years ago. 10 years ago, it's shown at the left. You randomly select 400 residents, and you have a level of significance of 0.05. Perform a chi-square goodness of fit test to tell whether this distribution matches 10 years ago or does not match 10 years ago, whether it fits that expected distribution. Okay, I have survey results. What is that? category if I had to label it? Survey results are what frequencies? Those are my O's. You do not have your E's. How are you going to calculate your E's? If it was uniformly distributed, it'd be n divided by how many categories you have. But the expected percentages right now are that they expect 16% in that first category. They expect 20% in that second category. So to get E, you're going to have to multiply your percentage by your n value, like we did earlier in the lesson. And you're going to have different numbers for each of those. Okay, and then if you want to check at the end, the sum of those should equal your n. Okay, then once you have that, you can do your O minus E squared over E, write your null and your alternative, you can do the big rejection test and answer the question. Okay, so I'll let you guys get started on this. We'll probably put answers up on the board, and then that'll be it for today. Okay. Put you guys together. Can you put up those top four variables on the right? N, K, degrees of freedom, X squared value. Okay. Audrey, can you do the null hypothesis? Right, that word. Juan, can you do the alternative hypothesis? And let's see. And you guys summarize. So drag that, drag a statement that goes along with it. Okay. And then can you, I drew the chi-squared graph there, large values on it. So draw the tail, the chi-squared value, and then all together. Yeah, so you're gonna have one where start shading, and the other one's at the bottom of that column. More on that graph. They'll put those values up for you, so you just gotta mark them. On, so we can move that actually. Well, you can move that up there, that's okay. This worksheet, which there are 2 questions on it, and the one you're meeting tomorrow, which is 1 question on it, are due Friday at the beginning of the period. This is your last 2 homework assignments. Okay. So don't forget Math Excel. You got 9-1 and 9-2 due over the next couple of days if you haven't finished those yet. Both worksheets due at the latest Friday when you walk into class, but again, it's only a couple problems. 1 problem tomorrow, so just as you get it done, if you guys want to drop it in the tray, that's fine. And those will be the last 2 homeworks we have. I also have for you your exam study packets. After tomorrow, the next 4 days in class are completely devoted just to exam review. So let me get you these. You've also got a digital copy of this on Polaris. Go. Oh my God. Did you not want me to prepare you well?
No, that is actually good.
Okay. All right. You don't have to do any of this. None of this is an assignment. It's not for a grade. This is just informational and whatever you want to do with it. Okay. So, day 2 and day 1 are swapped because of when you're going to be with me in the classroom taking tests versus when you are going to be at in the senior exam time taking the test. I don't know if I'll be proctoring that or not yet, so that's why. All right, so day 2, yes ma'am. I was going to ask for it. Oh yeah, okay, so if you want to put this at the top, guys, the first part of the test is Wednesday, May 11th in class. Okay, and that's going to be the extended response portion. Wednesday, May 11th in class, extended response. You're going to get a full hour, so it might go 15 minutes into the next class period if you need that full time. It'll only be a test to your next class period. The second part of the test you are taking on May 13th. Seniors, you are taking it during the senior exam time, which is 8:45 to 9:45 a.m. Okay, juniors, you're just going to take it in class on the 13th. 8:45 to 9:45. I don't have a location for that yet. I will let you know as soon as I know that. All right, so day 2, which is what you're going to take on the senior exam day on the 13th. That's all the multiple choice stuff. A lot of that is terminology, quick little calculations, z-scores, that sort of thing. To review for that first portion, there is a Math Excel. It is not, well, it's assigned, but it's not, there's no deadline on it. It's not due, it's optional. So it goes through all the different vocab that we've talked about throughout the semester. You're going to see a lot of stuff from the very beginning of the semester, like different kinds of sampling techniques, things that we really haven't talked about for a few months. So it might be good to refresh those, and the Math Excel questions are just vocab stuff, it's the calculations.
So is part 1 like mostly just vocab? Or?
So that'll be part 2. Will be
part 2.
Mostly vocab, but well, I shouldn't say mostly. It's about half and half. About half vocab, about half quick, smaller calculations. Okay, And all of this lists exactly what you're going to need to know for that portion of the test. So for the multiple choice portion, it lists all the different terms you're going to need to know. It kind of goes through, you're going to have to know like shape of distribution. You're going to have to remember your, use your empirical rule 65, 95, 99.7. You guys are going to get all your formulas and all your charts, just like you have for every test. So you're just going to need to again know how to use those. Some probability questions are going to pop up that day. And then explain the meaning of a correlation coefficient, for example, for chapter 9. So you can kind of go through this, think of this like a checklist of sorts. Then on day 1, that's the part you're going to take with me on Wednesday next week. Those are the extended response questions. There are going to be 6 questions, and that's where you're going to have to show all your work and do all your calculations. The multiple choice portion, your work is not graded, right or wrong, that's it for that half of the test. But then for the extended response, you can see exactly what you're going to have to do. So you're going to have to do 1 or 2 big problems where you're just doing all of those little calculations, mean, median, mode, 5-number summary. You're going to do confidence intervals, you're going to do a hypothesis test, and then you're going to do a big problem with R's that we were practicing this week, where you have to find the correlation coefficient, determine if it's significant, find the line of best fit that goes along with that all by hand. Everything here is going to be a basic red calculator you're going to be able to use on both portions, formulas given to you on both days. The practice test that is after that first page front and back, just a ton of practice questions. So answers to this are posted in Polaris already. You can use as much or as little of it as you want. You guys have this. You have Math Excel. You can use to practice vocab. And then you also have the clue game. If you can complete the clue game by Tuesday in class, next week, you get 3 bonus points added to your final exam. The clue game is 7 big questions. Actually, you just want to see that right now? I don't think I brought it up in here, have I? Okay, let's load that up. Shall we? There we go. All right, this is our folder in Polaris right now. Right below the WAG, you guys can see how to calculate your grade if you want to use that formula. Okay, everything is set. You've got a couple homework assignments that are going to go in, and then your last project, but your test category is done. So you can use that as kind of an approximation in the meantime, but you can use this to figure out what you have. There's also a second slide that gives you a formula there, so you can plug your averages that you guys see in Blackboard in to see whatever you're shooting for in the exam. As far as rounding goes at the end of the semester, if you have an 89.5, I will give you a 90. I will round up. If you have an 89.4, I will not round it up. It's going to be a B. So as far as calculating what you need to get an A, I would use an 89.5. It would be the lowest A that could be earned because that would be rounded up. Does that make sense? Okay, and then you have your 3 bonus tickets that can hopefully give you an edge one way or the other if you do the clue game. So final exam review at the bottom here, this folder has everything you need. The practice test is what I just handed you. That's the first page. And then you also have the solutions that go along with it. And then the study guide also. So that's all in this packet. The study guide is, I guess, the first page front and back with all the instructions, I guess. And then the practice test is everything that follows after it. So you have a hard copy of everything. The clue game, let me click on that. It will open up your own copy of a Google slide presentation. And your job is to figure out kind of a whodunit sort of thing. So there are 7 locations. There are maybe, I don't know why that's so small now, 7 suspects. Why is it showing me speaker notes all of a sudden? There we go. 7 suspects. And there are 7 weapons of math destruction. Okay. You have a scorecard. So your job is to eliminate the people that didn't do it, the locations that it didn't happen in, and the weapons of math destruction that were not used, and figure out exactly when, who, and with what did this terrible thing, whatever it is. Okay. How you figure that out is on the last slide of the presentation. You're going to click on one of the X's, and it will take you to a clue. So here's clue number 3. Bring it up. Open in a new page even. This will also make your own copy of it, so you guys can edit these as you like, write on them, print them, whatever you want to do. And it's a practice question for your exam. So this problem is a correlation coefficient problem. Gives you height and IQ scores. You need to find the R value and determine if it's significant or not. Once you have your answer, you're going to click the circle to submit your solution. It'll go. It's not loving my finger. There it is. It'll take you to a Google form, and you're going to answer the question. If you get all of the questions right, it'll give you green check marks for everything, and then you show me your screen in class, and I will physically give you the clue that you can narrow down your suspects with. Okay, so there are 7 sets of problems total. It's a great exam review. Okay, and if you get it wrong, you can do the Google form multiple times. Keep practicing, ask me questions if you want. You guys can work on it in class if you want. You can work on this practice test in class over those next 4 days as we review. All right. Any questions on any of that exam stuff? Yeah.
Wait, so for the next one, else you do want to go here?
So then, no, you can do like multiple of them at once. You just come to me as soon as you want the answer for getting your clue, for finding your clue. Yeah. So that makes sense. Yeah. So if you want to do 2 or 3 in a night and then get all your clues the next day. Yeah. All right, I'll do cell phone lotto. Yeah. Is that what you were going to ask?
Yeah.
Yeah. All right, number 4 is our winner today. Somebody won. Taylor.